all Max.
Nope, nerds.
Math.
Nerds. That's all you guys are. If you're watching math on YouTube, you are a nerd. By definition. Speaking of by definition, we're going to use that today in our proofs. Here we are. So, we know from number 2, from earlier. This is what we did earlier. I'm going to bring you up to speed. Okay, what we did. Haley, is this big enough for you? Can you see it? Okay, wonderful. All right, I hear other people are going to the eye doctor. Could you guys get like on a bus together like you did for the braces and I'll go do that? Speaking of which, if you know an optometrist that's good, I need one. I have money now, which means I can afford glasses for the first time in forever, and I'll actually be able to see. I might even get contacts and start burning up my corneas again like I did in college because I don't know how to blink. Have you ever noticed that? All right, so this thing right here. We know that JK and KL are congruent. They give us that, so I marked it that way. Now, I use color. Okay, which means I could use single marks for everything and just change the color up. As it turns out, all of these are going to be congruent, so it works either way. But HJ and GH are congruent as well. They give us that. And lastly, they say KL and HJ are congruent. So we have a little crisscross going on here. Yes, ma'am?
What is the, box next to given, what is the second letter? Is that a K? Oh.
This is not your eye test. I'm sorry. I'm not an ophthalmologist. So don't worry about that. And you're not allowed to cheat on those. So, do we see what they gave us? Wonderful. Now we're going to move over to the box. Okay, so what's the lowest line you can read?
Is that a U? Is that a K?
That's a K.
No.
She wants
on
to
the
know.
red box.
That's a K.
No.
The red one.
That's a K. H. That's a K.
Box. That
That's a
second
K?
letter.
Yeah, it's just got a little kick to it. That's all.
No, this is needy K.
It's like spicy.
Spicy.
Spicy. Just a little kick. All right, so that's a K. Yeah, it does kind of look like a U, like a really bad U, or like a fine K. All right, so here we are. They give us all this information. That's what I wrote down. I did it color coding so you can see the similarities here. We've got 2 greens equaling each other, 2 blues equaling each other, and then the crisscross that happens, right? The third thing they give us. Now, they want to know about GH and JK. Now, my advice to you is not try to think like, oh, man, I need to prove that they're congruent. No. Just get them in the same sentence. Just get them in the same room together, okay? If you can get an equation with GH and JK in it, the math will take care of the rest. This is how it works in real life too, okay? Don't try to make and make these people match up perfectly, okay? Don't do that. Just get them in the same room. The math will take care of the rest. Aww. If it's meant to be. All right, so here we are. JK and KL are congruent. We know that HJ and GH are congruent. We know that KL and HJ are congruent. My job in red is to get these 2 together, right? Just get them in the same room. Now notice they're not in the same room. We don't have an equation that has them in the same room. Otherwise our job would be very easy. We need to find a way to get them in the same room. So what do they have in common, right? That's what it's all about. That's where you start. What do they have in common? Well, this equation has a KL in it. This equation doesn't. But we have some stuff here that might link them together.
They're cousins.
Yeah, I hope not. Fun fact, my cousins are cousins, and they're married, and they're on their 7th child, I think. So seems to be working A-okay. Oops, they're like second cousins or something. It happens, right? I don't know. Straight out of Indiana. All right, close enough. All right, so here we are.
Okay. Let's keep going. 7 kids.
First cousins.
They just wanted to look like you.
What's your family's opinion on the situation?
Are they trying to make like an army or something?
How did you?
Okay, so anyway, back to this. We want to prove that GH and JK are compatible, and they are because they're two different things. Look, they're even colored different, right? We have a blue and a green, so they're going to go together, and they're not going to crisscross at all. So that's fine. So how do we link them? Well, this is the magic right here. Do you see how we have some blue and green already mixed together, right? So that's going to be our link. We know that GH and HJ are the same dumb thing, and we know that JK and KL are the same dumb thing. And we know that KL and HJ are the same dumb thing. So there's a link there. A way we can write that is this. JK and KL are the same. And KL is the same as HJ. And HJ is the same as GH, right? So we know they're all going to be congruent. Now how do we take that and put it in proof form? Here's the deal. I start out with the top, JK and KL. But instead of writing the same thing twice, I'm going to switch KL out for HJ. Now why am I allowed to switch KL out for HJ? Substitution allows me to do it. Now how do I know that those are substitutable?
They're equal.
They're equal. It says right there. They're the same dumb thing, right? If I told you KL was 5, couldn't you switch out KL for 5? Well, I told you KL was HJ, so switch them out.
Where's the U?
There is no U. That's a K.
God.
So here we are.
Oh, yeah.
Oh.
Don't do that on YouTube. All right, so here we are. By substitution. Next step. I've got these two together. Now I got to get these guys. Well, notice that HJ is the same thing as GH. So I can switch them out. Substitution. Right? And now I'm almost done. They want a GH on the left side. So I need to flip them. And the way I do that is symmetric property, right? A equals B, B equals A. And we're done. How you feel?
Mind boggles.
Dees? Again, just get them in the same room. And if it's true that they are congruent, the math will take care of the rest. Okay? It's a very beautiful thing. It's meant to be.
Only there's numbers.
You want numbers? You got numbers. All right, number 3. Overwhelming. But guess what? I'm going to put a piece of paper down, and it's going to be okay, because we're just going to cover up our problems. All right, here we are. So they give us that 1 and 2, the angle 1 and 2. We've got blue and green there for your health. Are complementary. They also say 2 and 3 are complementary. So green and pink are also complementary. Now, boys and girls, what does it mean to be complementary?
90.
Means, Mr. Mack, you look like Andy Samberg. Thank you very much. He's a beautiful person. What's the mathematical complementary?
90 degrees, right?
Yeah, they add up to 90, right? So I don't know where we're going here, but I do know that I should write down the stuff I know. So when it says they're complementary, that means to me that, boom, this is true, right? Blue and green makes 90. Green and pink makes 90. How do I know that? Because that's by definition. Now, if they haven't banned me yet, they're going to ban me now. I dare you, cowards. All right, so in the 80s, and I mentioned this before, okay, but we're going to mention it again for film. In the 80s, there was this thing called the porn wars. We've talked about this, right? And it had nothing to do with visual pornography. It had to do with music, right? So they called it pornographic rock because they had bad words in it. Remember, the 80s was a very puritanical time. And so this group of very concerned women, mostly women, got together and petitioned Congress, not the Supreme Court, but Congress, to make a law to ban music with any offensive language in it at all, like anything. And they failed, but they tried really hard. Frank Zappa showed up, and a couple other artists, including Alice Cooper, defended the case. And of course, most famously, as I mentioned before, the guy that was proceeding over this congressional hearing, again, not a judge, but a congressman, right? Which you know, you think judicial branch, but whatever. The congressman said that, famously, I do not know how to define what pornography is, but I do know it when I see it. Right? And that's what I want you to do. I want you not to be able to define all this stuff. I don't need to know the definition. I just need you to know it when you see it, right? That equals 90. They add up to 90. That's complementary, right? Why? Because that's just what it is. I know it when I see it. That's by definition. Whenever you feel like I know it when I see it, by definition is typically how we're going to justify it, okay? So here we are. Next thing, I numbered my equations so you can tell which one I'm dealing with. I take equation 1, and I mess with it a little bit. I'm getting a new perspective, right? So what I did is I subtracted angle 1 from both sides. That's all. See how it's angle 1 plus angle 2 equals 90? That's what we had before. I'm just subtracting angle 1 from both sides. That's subtraction property. Subtraction with the T, right? SUB property isn't enough because that could be subtraction or substitution. So that's subtraction property. What's going to happen? Well, that's going to go away, and it's going to move over here. We're going to get this. Now, why did I do that? Because I noticed that these two people, right? I need to get them together, 1 and 3, into the same room. I don't have an equation with 1 and 3 together. I need to make a room for them, right? I'm going to make an equation. 1 and 2 are together, 2 and 3 together. What do they have in common? Well, they both have angle 2 in common, right? So there's some hope here. They have something in common. So I need to figure out what that is. What it is. Well, angle 2 is this, right? I got angle 2 on its own. That's what it is. It's a bunch of junk. Now, if I got angle 2 equals 90, you'd know what to do, right? Plug it in. Now, it's 90 with a bunch of junk. That's okay, okay? Not everybody's going to have nice compatibility, right? It's going to be a little bit extra on there. That's fine. It's what we want. Because, again, we're trying to get 1 and 3 in the same equation. So when I take angle 2 and switch it out right here for all this junk, notice that junk has something in it. It's angle 1. So I'm going to get something, angle 1 plus angle 3 equals 90. I've got angle 1 and angle 3 in the same room. That's the goal. See how they're going to end up in the same room? Next slide. There it is. I know angle 2 is this, and I'm going to plug that in equation number 2. Instead of angle 2 plus angle 3 equals 90, I'm going to have all that junk plus angle 3 equals 90. And look what I have. A room, an equation with angle 1 and angle 3 in it. Don't worry about making them equal. Okay? If they're meant to be, the math will take care of it. That's how that works. So here we are. Why did I wrap that in parentheses? Organization, right? That's it. Just organization. It's all addition and subtraction. We don't really need them. I underlined it in green to show you that. Look, it used to be angle 2, right here. Angle 2 plus angle 3 equals 90. Substitution property is what allowed me to switch it out, right? They're the same dumb thing, so switch them out. Last step is I'm going to do some rearranging of this equation. Oh, no, I ran out of room. Did that happen to anybody when they did it over the weekend? No, because no one did. But if you did, you would have run out of room, which is why I suggested you do it on a separate sheet of paper, which is what I did. So, check it out. Here we are. I wrote the same dumb thing twice, just without the parentheses, because I know that confuses you. So here we are. Everybody cool with that? That's where we left off. Next thing I'm going to do is I'm going to move all this stuff over, because, right, doesn't this say angle 1 has to be on one side and angle 3 has to be in the other? So we got them in the same room. Now we got to get them situated, right? So here we go. I'm going to move over that angle 1. How am I going to move angle 1 over? Add it, right? It's a whole term. I'm going to add it, right, because it's negative. How am I going to move the 90?
No.
How am I going to move it? Subtract it. And why am I subtracting? Because if you notice, if I subtract it, it goes away. And that's good, because I only want angle 1 and angle 3 in the equation, right? So check it out. My next move is to do both things at once, because I'm a cheater. I subtract and add at the same time. Subtracting 90 from both sides, adding angle 1 to both sides. My pen exploded, I'm sorry. Hate when that happens, right? All right, so here we are. Am I less of a man? All right, now we're here. Things go away, and we have angle 3 on one side, angle 1 on the other. Now, the problem is, they want an angle 1 on the left and angle 3 on the right. Now, you know and I know it's the same dumb crap, right? 5 equals 3 plus 2, 3 plus 2 equals 5. You can write it either way. But the thing that allows us to do that is the symmetric property. So by the symmetric property, I flip them, and I know if they're equal. If angles are equal, they're also congruent. That's just a thing. Okay, we're ignoring that. At some point, we have to assume something. Let's assume that. And that's it, swag box. Now, we're going to walk through this again. I'm going to give you a couple seconds to take a gander and write this stuff down, because everybody's so eager to write it down. Yeah. You can just literally go on the YouTube video and screenshot it and like attach it to your homework, and we can call it a day. But you do you, okay? I'm going to walk you through this again. What?
If you keep following views, you get monetized, and then there's more money. Steady inflow, better equipment, life is great. Don't listen to them.
Okay, fair enough. I mean, I'm not arguing with any of that. All right, so here we go. No, anybody can be monetized. That's not how that works. But I am not monetized.
I mean, if you made us bring our homework to class every single day.
That's right.
I mean, you would pull 10,000.
I know. There are plenty of ways I can manipulate the system. People with money and resources, it's very easy to make money, right? But I'm good. No, you can be monetized without having to have 1,000. Anybody can be monetized. All right. The question is, will you actually make enough money? And if you have to hit a certain threshold of money, and once you've reached that, then they'll actually pay you. Otherwise, it kind of sits in a bank account that you never get to touch. All right, so here we are. How did I do this? Well, I started out with what I was given, and I interpreted that. I sucked all the stuff out of it. Well, I know they're complementary, so I wrote this. They add up to 90. That's by definition. Thank you very much. Is everybody cool with that? Let me go through it again since you didn't see it. I know these guys are complementary, so I wrote that. What that means is that they equal 90, right? How do I know that? That fits the definition of complementary. Are we cool at that point? Wonderful. If you're not paying attention, this is a terrible time not to pay attention. Like a terrible time not to pay attention, because these are proofs. You're going to suck at them. You're going to suck at them even more if you don't pay attention while we're learning the easy stuff, okay? So here we go. Taking equation 1, the top equation, I just subtracted angle 1 from both sides, that subtraction property. Again, all you need to know is that when I do that, I get angle 2 equals a bunch of junk, right? Which allows me to switch it out here. Now, why did I want to do that? Because that's what they have in common. That's going to be the thing that allows me to pivot and put 1 and 3 in the same equation, right? And that's what I want. So that's what angle 2 is. See how it has angle 1 in it? So when I plug that in here, I'm going to get something, angle 1, angle 3 equals 90. And I want that. I want angle 1 and angle 3 in the same room. So now I do that. I substitute there. Again, it used to be this right here. And this is a clear ruler. It used to be this. But now instead of angle 2, I write what it is. What it is, man. What it is. That's substitution. So now we got this. And you know from there, I'm going to subtract the 90 and add the 1. And I'm going to get angle 3 equals angle 1. Right? Because the 90s go away and the angle 1 moves over. That's what I did here. That's all. And I get this. That's it. And now I flip them by symmetric property, and I get 1 is congruent to 3. 1's on the left, 3 on the right, which is what they wanted.
So all this is just a bunch of moving?
It is. It's just like the letter thing we were doing for the warm-up. It's moving things around and using the rules that you have at your disposal, the proofs toolbox, right, to move stuff to make it what it needs to be. That's it. That's it. It's a puzzle. Now, puzzles are hard because there's lots of different moves you can make. It's not PEMDAS, right? If I do parentheses first and exponent second, blah, 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 right, and I'll be fine. No, that's not how it works. In fact, it never did work that way. But we were too afraid to teach you real math, and so we gave you that little thing to hold on to. And so for all the problems that we gave you, it worked just fine. But that's not really learning. It's memorizing. And memorization should happen naturally from learning, I think, not the other way around. All right, that's that one. Now, take a look. Take a gander at number 4. It says 1 and 2 are supplementary. What does it mean to be supplementary?
180.
Try again. Linear pairs on the same line. There's something similar with that, right? It's that they add up to 180. There's a connection there, right? If they're on the same line, they will be supplementary. If they're supplementary, they add up to 180. I smell what you're stepping, okay? So probably going to write that down first, right? Like, you're given they're supplementary, therefore they add up to 180, right? This one, I write the same thing twice. That should read angle 1 is congruent to angle 4. Angle 1 is congruent to angle 4. That's what that should read. Again, no one brought it up to me, so I know no one did the homework over the weekend, which is funny. Again, everything's made up and the points don't matter. That's how homework works in here, so God bless you for not doing it. Although I would encourage you to try it on your own at home. That way you can find out your mistakes before you try it on your own here during the quiz, right? That's the idea. But you do you. 3 and 4 are supplementary as well, it says. So that's a thing. We're trying to get 2 and 3 in the same room, right? Who cares what else you bring with? Just make sure 2 and 3 together. And if they're meant to be, and they will be because this is a possible proof, then the math will take care of the rest. Okay? That's how true love happens. You get together, you find out what you have in common, right? You swap some stories, the math takes care of the rest.
And then you find out.
Even if you're cousins.
Even if you're cousins. In fact, if you're cousins, you have extra in common. All right, so. That's right. Actually, fun fact, did you know that just by being humans, we share 99.99999% of our DNA? Which is why when you watch CSI or actual people doing like crime scene investigations and trying people and sending them off to die because they found DNA evidence, it's all pseudoscience. Pseudo meaning fake. You can't, like we share so much evidence, like DNA, like with us, right? That's not valid evidence. That should not be valid evidence. Like, imagine there's a guy with a hook, right? Okay?
What'd you do last summer?
Right?
Why?
And I know the only way they get me is DNA evidence, right? Your blood's going to get everywhere because I've got a hook. You're going to have DNA everywhere. So I like the odds of my DNA not being traceable because it's pretty similar to yours, like almost all of it, right? Yeah, I like my odds, which is why when we sentence people to death on death row based on DNA evidence alone, this is a bunch of bullshit and we shouldn't be doing it. Last thing on that, if you're doing a 23andMe thing to figure out your heritage and all that crap, that's a bunch of BS as well. They can't tell whether you're Irish or Scandinavian or what have you based on 0.0001% difference from somebody else that's in, I don't know, Africa, okay? It's just not a thing. It's just not a thing. It's just not a thing.
So you mean to tell me I'm cousins with Bill Gates from like super long ago?
That's not at all what I said, but you can watch the video in reverse and rewind it and go back, right? And you'll pick it up next time, I'm sure. Number 5, they tell you that A, B, and C are collinear, but they don't tell you what are A, B, and C. Well, A, B, and C are there. I drew the dots in for you. Now they're there. All I'm saying is that we got 2 lines here. They're intersecting. I want you to prove that 1 and 3 are congruent and 2 and 4 are congruent. Okay? If you're clever, you'll realize, hey, we have a theorem for that. We do. It has something to do with these. What are these?
Scissors.
Your words, not mine. Your words, not mine. I never called this scissor theorem. It was your words. I'm just going with it because it's relatable. They came up with the idea themselves. Okay? So scissor theorem, right? Right?
Yeah.
All right. Then prove that angle 1 and 2 are supplementary and 3 and 4 are supplementary. Supplementary means they add up to 180, so that's what we're trying to prove, right? It's not enough to prove that they add up to 180. The last step is to say if they add up to 180, therefore they are supplementary because that fits the definition, right? You need it to look like this. Not an equation, okay? End your proof with that for those guys. So when you get the equation that says they add up to 180, last step is, therefore they're supplementary by definition. Okay, wonderful. That'll be for you, okay, for your health at home. Let's take a gander at what we're doing today. Oh, I've decided what to do. Instead of giving them away as souvenirs, I've decided to take all the stuff that I make in class and do notes every day, and I'm going to make a mural on the back wall. That's what we're going to do. We're just going to put it all up
You should
there.
make colored glass. Is that what it's called?
Colored glass. Stained glass.
What? Stained glass.
Let's miss it.
All right, this is the problem that we're going to be dealing with today. If we have time for more, we'll do more. Here's the idea. So we've got an angle. That's a V, okay? TVK. That's what we've got going on here. TVK, they tell you, is 90 degrees, which is why I put a 90-degree angle, right? Grandpa SquarePants, never chase after a bus that's going up at a 90-degree angle, rock bottom. That's TVK. The blue angle, which is TVX, which we'll try not to call it that. Words are hard, colors are easy, right? The blue angle plus the KVX angle, the orange one, they should add up to the whole thing, right?
Yeah.
What we're trying to prove is that they're complementary. What does it mean to be complementary? Mr. Mack, you look like Andy Samberg. I know. You also look at the guy Nicki Minaj, right?
You also look at the guy in the chick shop.
Nicki Minaj.
You do look like the guy from the chicken costume.
I might be him. Yes.
So is geometry just like common sense?
Now that you say that.
It's just walking it out. That's what logic is, right? All of math should be that way, right? If you understand why it works, how could it be anything else?
Where's Woody?
Right? So here we are. So we're trying to prove that those two angles, the blue and the orange, are complementary. Now again, what do we know about the blue and the orange angles? What else do we know?
They're, they make a right angle.
They make up TVK, don't they? What's the thing that says the two little bits make up the big bit? What? No, they don't have to be half. They don't have to be 45 and 45. They could be 30 and 60. Right? That would add up to 90. They could be 1 and 89 for all you know. Common assumption. What do we know about the two bits adding up to the whole bit?
Wait, what? Say
Come on, proofs toolbox. Take it out if you need to. What thing in our proofs tells us that we can have the two bits adding up to the whole bit?
something.
These are angles, right? Yes.
Postulate.
Yes, it is a postulate. It's so obvious. Of course they add up to the whole thing, right? And we know what the whole thing is, luckily. It is 90. So that's going to be useful. We call it the angle addition postulate, right? The two little angles add up to the big angle. That's all. AAP. We have a segment addition postulate that says the same thing but with segments. You love that one. So let's just write down what we know. Well, given, and again, it's going to seem silly to write this down, but it really does help. And you guys need all the help you can get because you guys are morons when it comes to proofs, right? You have no idea what you're doing. So given this, we're given that the measure of angle TVK equals 90, and that's a K.
I can tell. I've sloppy writing. So I can tell.
And I'm going to do that in red so we know what we're talking about, right? TVK is 90. We're given that. We're trying to prove that TVX and KVX are complementary, meaning that they add up to 90, right? So if we get there, we're basically done. So I said angle addition postulate. Now, angle addition postulate tells me that the blue plus the orange should equal the whole thing, right? So let's write that, right? So the blue angle is this guy, TVX. And that should add with what other angle? Haley. V, and what's the last letter you can see?
X.
X, very good. Very good.
What is it?
It's actually a Q, but you know what? It's fine. Here we go. Equals. What angle? What angle is it going to equal?
TVK.
TVK, the whole dumb thing, right? So I know this based on what? What allows me to say that? That I can put the pieces together and get the whole thing?
The angle, whatever.
Angle addition postulate. It's AARP without the R, right? So no retired.
God.
American Association of Retired People, right? AARP. Which is AAP, angle addition
Yeah,
postulate.
we're
Yep, that's true.
We are
So here we are. So now we have this. Well, we need to prove that these two guys add up to 90, but we've proven that they add up to an angle. How do we prove that they add up to 90? It says it right here, right? We can substitute it. See how that is 90? They're one and the same. So we can switch them out. We call that substitution. So I'm going to write the same dumb thing, except I'm going to substitute. Instead of writing TVK, I'm going to write what? 90. And that gets us almost to what we need, right? We need to prove they're complementary. Complementary means they add up to 90. That's the definition. Hint, hint, hint. We get this. Equals 90. Haley, are you okay?
Yeah.
I question my mental
Shoot,
state.
technically it's KU. What?
Oh.
U's have tails.
My inner demons are screaming at me right
Yeah,
now.
capital one does.
Calm down, Jerry.
What does subs with an S on the end stand for? Thank you very much. As opposed to subtraction, which has a T. S-U-B is not enough. Okay? So that's by substitution. We switch these guys out. Do you smell what I'm stepping in here?
Yep.
Okay, wonderful. Now we have this. We need to prove that they're complementary. We don't need an equation. We need a statement. So how do we go from this to a statement? We write it, first of all, right? Therefore, and I'll keep the colors. I'll keep the colors. TVX, I should say. And, what's the name of this sign? No. It's an ampersand. What's the name of this letter? W. No, it's a W. R. What are they? What does that mean they are? Come on!
How?
Complimentary.
Thank you very much. Now, how do we know they're complementary? That's by definition. That's by definition. Of course they are. I know when I see it. When we have two angles adding up to 90, it's complementary. Gentlemen, we doing all right? Sloffer, I think it's time to put away the phone. Thank you very much. And now we're done, because that's what they wanted, right? They wanted us to say that they're complementary, and we did. There they are. Thank you, sir. All right. Yep. Coordination is not your thing today, buddy. All right. Questions, comments, concerns, other than for my mental stability?
No.
Good job, Rosie.
Dykema, you gonna be okay? I need the room mic to be on, because like no one can hear any of this on YouTube, and it's just me talking to myself. I'm not a real teacher. I'm just some crazy guy at home. I'm just talking to my microphone, making up stuff. But I am a good actor because I've never goofed up their names. Yikes! All right.
Like really.
All right. So there we go. All right. That's a proof. Do you feel like you could do that one on your own if I asked you to do that on your own?
Yeah. No.
I could try.
Just because I didn't pay attention. That's on. See that?
Let's take a look at another one.
Oh.
It is.
Ew.
Hey, Andre.
Is this a lot more energetic than what it was Friday?
Yes, and I appreciate that.
Friday we were all dead.
All right, so check it out. It was hastily written, but it was written nonetheless. Okay, so we have two triangles that are overlapping. They create three triangles, right? This is like the thing I did that you guys sucked at. So here we are. We have triangle AEC, the big one, and we have triangle BFD, the other one. We have a triangle down here, which will remain unnamed because we didn't name that point because we don't need it. They give you that those two triangles are equilateral. What does it mean to be equilateral by definition? Same. Equa means same. What does lateral mean? Side, right? So same sides. Same sides. Now you know an equilateral triangle also happens to have same angles, which means it's regular, which means they are congruent to each other. So those two triangles are congruent. They also give us that EC and BF are congruent. EC is this bit, and BF is that bit. So let's mark that. This and this, those are congruent. We need to prove that AB and CD are the same. Here's AB, here's CD. Okay? So first we're going to write down what we've been given. So we've been given that triangle AEC and triangle BFD, which it is, are equilateral. Are we doing okay? Because we're doing a lot of talking about stuff that I don't think really matters, and it's not really that funny. Not because I'm a teacher and it's not funny, but because it's just like generally not that funny. It was funny, but it wasn't that funny.
Caden was just talking about how I did off football today.
Gotcha.
Football.
Gotcha. I know that's a thing I do, and it's a joke, and we can handle it, right?
Cool.
Okay. Because like repeating the joke really is just boring, and like what's worse than repeating the joke is having somebody else repeat the joke back to the person who just did it. He said football, right? Like, come on. All right, so we know these triangles are equilateral. We also know that EC and BF are congruent. Okay, so let's talk about that. EC and BF are congruent. EC is congruent to BF. Now, what is our goal? We're trying to prove what? Somebody tell me.
That they're equilateral.
AB equals.
AB and CD are congruent. These two bits, right? Those two bits right there.
Yes.
So if we know they're equilateral, what does that mean about all the sides?
It should be the same length.
Yeah. So therefore, we know all this. You ready for this? AE is congruent to EC is congruent to CA. You see what I'm saying? All three sides of the triangle are the same.
Yep.
Now, we know that that's an equilateral triangle. We know that's an equilateral triangle. How do we know that they're equal to each other? We don't, right? I can draw lots of equilateral triangles. Here's an equilateral triangle. Here's another equilateral triangle. They're not necessarily equal. What's the thing that's going to allow us to say that those two triangles are going to be, in fact, congruent?
The
Equilateral.
These two guys are the same.
yes.
So again, we know this by definition of equilateral. So that's by def. So that triangle, this one over here, the left triangle, is congruent to itself. All the sides are, right? But we also know that BF is congruent to FD is congruent to, let's do DB. We know this. Now, how do we know that these guys, this and that, are the same thing? The link is here. EC and BF. Here's EC and BF. See how they're the same?
Yell at him.
Andre, please. Like,
anything like the alpha.
It's not working for you, man. Like, we know this. It's not working. We gotta try something different. Try something different. All right, here we go. So these are the link, right? If those two are the same, and these guys are all the same, then everything is the same by the transitive property. So I know, therefore, that all these guys are going to be the same. AE is congruent to CA. I'm going to write CA next. And that's congruent to EC, which we know is congruent to what? BF. Congruent to FD, congruent to DB. So this is by def. Oops, switch these guys. That's not how colors work. This is by def. How do we get, our goal is to show that EC and BF are the same. How do we get that? Or not, that's not our goal. AB and CD, how do we get them the same? AB is nowhere. Try this one at home.
It's impossible to solve. That's the one.
That's the next step.
Thanks, Jake, for that.
Yeah. That's hilarious.
I'm sorry for my accent.
Hint, segment addition postulate. Yeah, thank you.
I'll be better tomorrow.
Thank you.
And if I'm not, I'll get a detention.
Yes, you will. Goodbye,
Yeah, I
May.
have no idea what we're doing. I'm terrified of this lesson.
All right, so here's what I need you to do. I need you to come in and see me and do something about it, okay? Let's do that.
Also, do we have games club?
We do have game club today.
Right.
All right? Being terrified is okay. Just make sure you do something about it, all right? Later.
Because it increases the chance of a psychological scarring.
No, it decreases, but it does increase the chance of learning, which is ironic.
Well, isn't that a problem, man?
You think Jake will say
YouTube, this takes a little while. I'm not sure why. Been slow lately.